This video will contain the last practice exercise for lesson number 2 of linear inequalities. Here we are still going to solve the values for possible values for the variable, which is actually termed as solutions, and present them in a form of linear inequality form before presenting it to the other three forms such as solution set, the graph, and the interval notation. So in make coming up with the correct and proper linear inequality form, we just need to follow and apply the different properties of inequality presented in our module. For number one here, we need to remove first this constant here by adding both sides by 2. Then we have 3x is greater than, that's 0 already, 12. And then we divide both sides by 3 to cancel that out. X is greater than 4. Before we could come up with a solution set, again, the graph and interval notation, let's try to check. A number greater than 4 is to be substituted in the given inequality, and if the inequality holds, that means that our linear inequality form is already correct, and we are ready to show it in the other different forms. A number greater than 4, my best advice was 0, but since 0 is not part here, you could pick any other value. Let's say 5. So let's substitute here 5. That's 3 times 5 is 15 minus 2. We are still checking, so that's question mark. 15 minus 2 is 13. Then 10 here. 13 is really greater than 10. That means this is correct and this is not acceptable as true. So all values greater than 4, that would be our solution set. I mean our possible solutions, and our solution set shall contain x such that x is greater than 4. Our graph should extend towards both infinities. Let me draw here arrowheads to denote continue, uh, continuous movement of the real number line. That's positive infinity. So we start here by 4 and we go to the right. So shade everything here going towards the right. You may add, and not may, you need to add arrowhead to denote that it does not end. And decide finally if 4 is included. Again, you have two options to do that. First is substitute that endpoint uh, in our given equation. If we substitute here, 3 times 4 is 12, minus 2, 10. So you have 10. Is 10 greater than 10? No, because they are equal. That would mean that 4 is not included. The second, that's the first option, substituting in the given equation. The second option is just simply to look at the symbol, the linear inequality symbol. Since it doesn't have equality here, just like that, that means 4 is really not included. In our graph, 4 should be an open circular figure. Let me erase here. And then we add parentheses going to this direction. This is now our complete graph. As for our interval notation, refer to this one. The leftmost value until here is 4. The rightmost value is towards positive infinity. Let me make it better. Or better. 4, we use parentheses here, so it's open. And infinity is always open. So these are now the processes involved in item number 1 for this practice exercise B. Let's try to go to item number 2. Here in item number 2, we notice that in on your left-hand portion, no other values, no other constant, just like the number, unlike number 1 here. So it's already okay here. However, for the right-hand side, unlike number 1, which is already in constant form, we have here the variable x. As much as possible, we would like to make sure that the left-hand side of the linear inequality should contain the variables x, x, and so on and so forth. And the right-hand side of the inequality should contain the constants. So in this case, since here we have a variable on the right-hand side, we don't like it here, we need to remove that. And to remove that, we will subtract x here and also subtract x on the other side. So the other side, the left-hand side shall become -2 minus 1. Check your integers. You have -3x. This will become 0. This would become 6. Since we're just simply subtracting, no changes on the inequality symbol. Take note that it could only be changed if it's multiplication and division of a negative value, which is actually in this next step. We will divide both sides by -3 to remove that. Divide also -3 here. So the final result, that's x, here -2, and this should be the right time to interchange it. Let us try to determine if our process, our interchanging of inequality sign will make our equation, our inequality still correct. So a number less than -2 could be -3. Let's substitute it here. So -2 times -3 is +6. Again, that's -2 times -3. The other side is -3 plus 6, which is actually +3. Is 6, using this one, is 6 greater, not this one, huh? The given, because we are checking. Is 6 greater than 3? Yes. This means that our solution here in the linear inequality form is correct. Again, when we check, we always refer to the given values and symbols. But when we make our graph, interval notation, and even a solution set, we only refer to our linear inequality form here. That being said, our solution set is set of x such that x is less than -2. Our graph, let me move it here. Again, it should extend on both sides to -infinity and +infinity. The starting point rather is -2, and it goes towards the left. Arrowhead here. Okay. And then -2 is not included because of this. So we open it. Take note that our graph again is based on linear inequality form, not the given. The given inequality symbol is greater than, it points to the right. However, the final inequality symbol for the linear inequality form is less than, going to the left. That's why we shade it to the left, not to the right. We open it and add a parenthesis here. Let's make it better. It should be at 2. It should pass 2, right? And -2 rather. And then finally, for our interval notation, the leftmost value is -infinity. The rightmost value until here is -2. Separate them by a comma. -2 uses parentheses. Infinity always use parentheses. This is our result for item number 2. So again, we need to come up with an expression wherein the left-hand side will come up with the variables and the right-hand side with the constants. That's true for number 2 and very true as well for item number 3. Because in item number 3, on the left-hand side, we have constants to which we don't like. Not necessarily don't like, we don't need there, rather, that's the term, we don't need. And the right-hand side also has variables to which we don't need it there. So to do that, let's remove them. But first, let's take it step by step. Let's remove first 1 by subtracting 1 both sides. Let me remove this so that it will not be uh, misinterpreted as a division. So that's 0 already. This will become 3x. That's 0 greater than or equal to x minus 1, check your integers, minus 2. And then remove the x here by subtracting x both sides. So you have here 3 minus 1 is 2x. Still a symbol is greater than or equal. And you have here negative 2. That's 0 here. And then divide both sides by 2. By 2. That's cancelled out. Value here x. Here is negative 1. And the sign will not change. Again, even if this is negative, our concern for changing of signs is the denominator. Since denominators are positive, it will not change the inequality symbol and it stays as it is. Let us pick a number on that in this inequality form to determine whether an inequality form is correct or not. You could pick negative 1. You may do that, but my best advice is to use 0. As to why, it's easier to do that here. 3 times 0 is 0. Plus 1, I have 1. Diba? Easier. On the other side, 0 minus 1 is negative 1. You have less than or equal. Is 1, not less than, rather greater than. Is 1 greater than or equal to negative 1? The answer is yes. As therefore, this is correct. And then complete the remaining 3 forms. Solution set is x such that x is greater than or equal to negative 1. Close it. Our graph, again, extends here, negative infinity, positive infinity, and it starts with negative 1. It goes to the right based on this form, linear inequality form. So it should be properly shaded, but as of my shading, my graph, I cannot shade this properly, but it should be properly shaded and should have an arrowhead. All right. And then negative 1, since we have the equal symbol here, is included. So let's just make the circular figure bigger. And then we will use brackets. Okay, that's for your graph. And for your interval notation, to complete this practice exercise B, leftmost portion is negative 1, rightmost portion is positive infinity. Infinity is always open, but 1 here is, but negative 1 rather, is included and it should be closed by a bracket. So this is our result for item number 3. What is different from the previous practice exercise is that there is now a presence of terms to which we don't need on specific areas. We need to remove them. Right? So the processes will still follow the properties of equality and the presentations in correct formats. So this is the last practice exercise for unit number for lesson number 2 of unit number 3. Right? So please review for this one. You need to master this before we go to lesson number 3, which is now on linear inequalities in one variable involving absolute value notations. That would be for the next module and for the next videos soon. Thank you very much for watching. Please be excited. Goodbye.